staying with some more properties of logarithms. We're talking about a change of base formula, which for most of you is an easy way to solve exponentials, logarithms, where it's not base 10, which is on your calculator, or base e, which is that natural log that's on your calculator. So what this is telling you is you can switch it out by putting the base on the bottom. Grant, where's the base go?
On the bottom.
Maria, where's the base go? JP?
On the bottom.
See how that works? The base always goes on the bottom. So, you got it. So, on an example like this, there are two numbers in the problem and you're looking at it, it's log base 5. That does not work on the calculator. We only have two buttons on the calculator. So we're going to put the base 5 on the bottom and that other number goes on top. And now you can choose what you want to do. Do you want to do the ln or do you like to do the log? So maybe in this case we'll do log, which remember is really, I'll just write a small base 10 in there. It's really base 10, base 10. So type that in and get your answer. Over here, we can do the same thing, and we can put 42 on top, and the base 2 goes on the bottom, but maybe this time we'll do ln. Just so you know, whenever I do a base change, I am that lazy. I will write ln every time because it's 2 letters versus 3. I mean, literally, that's the only reason I use ln all the time. No. No, go ahead and check. I mean, you can even do ln of 18 over ln of 5. If I do log of 18, and when you hit the logarithm button, either one, it gives you the parentheses. You have to make sure you close it. Make sure you close it before you divide by the log of 5. Or somebody else might be hitting the ln of 18. Close it before you divide by the ln of 5. So notice I get the same decimal. So the only issue is closing it on that first logarithm, and do not go one logarithm, one natural log.
Can you round it?
So what? I didn't even look at the answer. What was the answer here? 1.795. What did we get over here? Natural log of 42 divided by the natural log of 2. 5.392. What? Right. So, the last thing we're going to talk about there are exact values there and the approximations. When you write it out as a base change, it's still what's called an exact value, and most of the time that's an okay answer. There will be times that you have to go to the approximation because nobody walks around saying, hey, you know, my brother's the natural log of 42 divided by the natural log of 2 years old, right? Somebody punch you in the face when you do that. So, starting with you. So base change formula. Some more properties. Properties of logarithms. They're here. If you are taking the logarithm of a product, you know, right here. So I'm taking the logarithm of something, and you can break it up into factors. Then you can take that same logarithm of each of those factors by adding the parts together. If you're dividing, you would take individual logarithms of those factors again with subtraction between them. And then step 3, this one, it's kind of a nice little feature. What happened to the exponent? The n.
Front.
It went out front, right? So if you're applying a logarithm of an exponential function, you can bring the exponent down in front as multiplication. So expand the logarithmic expressions. it might also say write as individual logarithms. What base logarithm is this, by the way?
10.
Okay, so I don't have to write it. I just want to remind you every time we have the opportunity. So this is log base 10. So we're going to do, this is 2 times x cubed times y to the 4th. So you can go logarithm of 2, logarithm of x cubed, logarithm of y to the 4th. What goes in between each part then? When you're working with a product, what do you put between them? Addition. Plus. Right? So you take the individual factors, they each get their own logarithm, and then you're adding those parts together. Anything else we can do to simplify? Let's bring the exponents down in front. So this would be the log, and you could call it base 10 if you want, of 2 plus 3 times log base 10 of x plus 4 log base 10 of y. So this would be our final answer. That's the most simplified thing we can do. Is 10 to some power equal to 2 a really nice number? No. So that logarithm right there can't be done. Questions on that one? So expand the logarithm or write as individual logarithms means pull it apart into all these tiny pieces. What are you going to do here? We're dividing, right? So I'm going to take the logarithm, natural log, of the top. I'm going to write it, though, as x plus 5 all raised to the 1/2 power. That's the same thing as the square root. And I also have the natural log of y squared. What goes between them this time? When you're dividing, you subtract between them. Now what can I do to simplify? Bring any exponents down in front. So the 1/2 can come down in front. The 2 can come down in front. And that would be a simplified answer. Condense the logarithmic expression, or they will say write as a single logarithm. So one of the first things we can do is put exponents back up top. So I have log base 10 of x squared minus log base 10 of y. And when I bring the 1/2 back up on the z, I'm going to call it the square root of z. Now, I wrote negative, but I forgot to put the 3 up here. Thank you. So we forgot the 3 there. Now, some of you might be saying, why did you write the -3 up there? And you can. You can. What's going to happen to the y then if you put y to the -3? What would happen to y to the -3? Becomes 1 over y cubed. Right? Because the negatives cause your base to flip into reciprocals, and then you cube it. 1 over y times 1 over y times 1 over y is 1 over y cubed. So watch what happens. I did not take the negative up there. Now, when you look at what we have left, we always check. Okay, base 10, and I didn't write it here. This is base 10. All of my logarithms are base 10. Those are the only ones you can squish together. Only the ones that have the same base can you squish together. So we're going to have one big log base 10. Positive terms get multiplied together and they go on top. Negative terms get multiplied together and they go on the bottom. So which ones are positive? X squared and z. So x squared and the square root of z go on top. The negative comes from y cubed. It'll end up on the bottom. So remember up here when we said y to the negative 3, we ended up with 1 over y cubed. So if you take the negative, it'll become a positive term. Now all of them are positive. Y cubed ends up on the bottom anyway. One single logarithm. I'm going to give you a head start and look at part B here. I want you to just simplify what's in parentheses. Don't worry about this 1/3 yet. Keep it out front. Just do what's inside here. Alright, so I gave you a little bit of time to work on it. I said keep the 1/3 out front. So inside, we're going to put the 2 back on the x. We're going to put the 4 back on the y. And then what I would do is I'd say, well, the x squared is the only positive thing. So I have 1 natural log. So x squared is positive. That goes on top. I have 2 negative terms. Those 2 things, y to the 4th, z plus 2. That goes on the bottom. So all of them are ln, so I can combine all of them. Positive stuff goes on top, negative stuff goes on the bottom. It's multiplication, division, that kind of thing. And then the 1/3 now can go on top of this one. So you could write it like ln the cube root of x squared over y to the 4th z plus 2. And some people might even simplify more, like the cube root of x squared and the cube root of this stuff, but we're going to stop there.
There's no base 10.
ln. What base is ln? We're in base E.